आज हम लोग क्लास 12 का शुरुआत किया जाए। शुरू करेंगे फंक्शंस की प्रॉपर्टीज से। फंक्शंस का डेफिनेशन बेसिक्स क्लास 11 में थोड़ा हम लोगों ने सीखा था। तो बिफोर गोइंग अहेड विद द प्रॉपर्टीज, फंक्शंस के डेफिनेशन को थोड़ा सा रिवाइज कर लिया जाए, बेसिक फैक्ट्स को, और फिर उसके बाद जो भी प्रॉपर्टीज हैं वी विल स्टार्ट विद द 1 एंड ऑन टू फंक्शंस। इन प्रॉपर्टीज को पहले डिस्कस करेंगे। तो पहले डेफिनेशन अपना रिवाइज कर लिया जाए। फंक्शन जब हम लोगों ने डिफाइन किया तो इट वाज डिफाइंड एज अ रिलेशन फ्रॉम वन सेट ए टू अनदर सेट बी। और फंक्शन बेसिकली एफ जो है, ये जो डिफाइन होता है, इट इज अ सबसेट ऑफ द सेट ए क्रॉस बी। ए क्रॉस बी कलेक्शन ऑफ ऑल ऑर्डर्ड पेयर्स a comma b, a coming from a, b coming from b. So any relation will not be a function. So the relation to become a function, the conditions were that for every a x belonging to a, there is a unique y belonging to b such that x comma y belongs to f, also written as y is equal to fx. The equation form is generally used when we are dealing with sets A and B consisting of real numbers. Then we prefer this equation form. If A and B are any general sets, then this ordered pair form is preferred. Both have their advantages and disadvantages. So we will be primarily using this because the functions that we are going to discuss mostly will be having your a and b as subsets of real numbers. So if you recollect, this set A is called domain और B को हम लोगों ने कहा था कि ये हमारे फंक्शन का कोडोमेन होगा। और फिर हम लोगों ने एक रेंज डिफाइन किया था। रेंज जो है all y belonging to b such that y is equal to fx for some x belonging to a। मतलब रेंज जो है वो कोडोमेन का सबसेट होता है। इसीलिए जब ये फंक्शंस हम लोग डिफाइन करते हैं, the functions when they are defined, we say that f is a function from a into b। और फंक्शन के भी कैरेक्टरिस्टिक हम लोग सीखेंगे, जिसमें हम लोग कहेंगे कि हमारा फंक्शन ऑन टू फंक्शन। सो जब कैरेक्टरिस्टिक सीखेंगे तो उसमें हम लोग ये देखेंगे कि फंक्शन को ऑन टू हमको तब कहना है जब ये जो रेंज है वो एग्जैक्टली उसके कोडोमेन के बराबर है। तो ये बेसिक डेफिनेशन था। थोड़ी इस पे 2 एग्जाम्पल्स करके देख लीजिए व्हाट दिस फंक्शन डेफिनेशन इज ट्राइंग टू से। और द एग्जाम्पल्स जो भी हम लोग लें वो इक्वेशन बेस्ड एग्जाम्पल ही लिया जाए। और कोई भी इक्वेशन जो 2 वेरिएबल का एक्स और वाई का हम लोग देखते हैं, एवरी इक्वेशन ऑफ 2 वेरिएबल्स एक्स एंड वाई कैन बी ट्रीटेड एज अ फंक्शन प्रोवाइडेड वी आर एबल टू असाइन अ डोमेन एंड अ कोडोमेन। तो जो वेरिएबल डोमेन से आता है उसको फंक्शन का इंडिपेंडेंट वेरिएबल कहते हैं, और जो वेरिएबल कोडोमेन से आता है उसको फंक्शन का डिपेंडेंट वेरिएबल कहते हैं। और वो डिपेंडेंसी जो है, जो इक्वेशन हम यूज करेंगे, वो रिलेशन तय करता है कि किस एक्स के लिए हमको कौन सा वाई देना है। तो इंडिपेंडेंट वेरिएबल्स का कलेक्शन जो है वो डोमेन, और डिपेंडेंट वेरिएबल्स जिस सेट से आते हैं वो कोडोमेन है। तो कोई भी इक्वेशन जो हम लोग हैंडल करते हैं दो वेरिएबल में, उससे हम लोग एक फंक्शन क्रिएट कर सकते हैं। अपने आप वो एक फंक्शन नहीं है, अपने में वो सिर्फ एक इक्वेशन है। वो फंक्शन तब हो जाएगा जब आप उसके वेरिएबल्स को एक एक सेट असाइन कर दो और फिर ये सारे कंडीशंस फॉलो करने चाहिए। तो जो एक दो एग्जाम्पल्स इस तरह के देख लिए जाएं ताकि अपने जो बेसिक फैक्ट्स है वो रिकलेक्ट हो जाए। सो वी विल गो अहेड विद आवर प्रॉपर्टीज ऑफ द फंक्शन। एक इक्वेशन लिखा जाए, से 3x plus 2y is equal to 5. At present it is an equation. अब मैं मान लीजिए कि एक सेट ले लेता हूं, x belongs to 0, 1, 2 और ये हमारा सेट A हो गया और एक y के लिए सेट कंसीडर कर लिया जाए, 0, 1, 3, 5, ये हमारा सेट B हो गया। तो अब ये जो इक्वेशन है, दिस विल डिफाइन अ फंक्शन फ्रॉम A to B प्रोवाइडेड ऑल दोस कंडीशंस दैट वी मेंशन्ड आर सेटिस्फाइड। हमारे कंडीशंस थे कि फॉर एवरी x बिलोंगिंग टू A there is a unique y belonging to B. So for every x belonging to A, so x is equal to 0 ले लिए, तो x is equal to 0 ले लिए, तो y is equal to 5/2. 5/2 is not in B. So this equation is not going to define a function from this A to this B. This is what has to be understood. Equations will define a function. इक्वेशन से फंक्शन बनेगा, लेकिन फिर आप उसका डोमेन और कोडोमेन प्रॉपरली चूज करें ताकि जो डेफिनेशन में कंडीशंस कहे गए हैं वो सेटिस्फाइड हो, वो वायलेट ना हो। कंडीशन चूज करना है तो मान लीजिए कि आपने बी को ऐसे नहीं लिया, आपने वाई को कह दिया कि बिलोंग्स टू सेट ऑफ ऑल रियल नंबर्स, ये आपका बी हो गया। अब आप x इज इक्वल टू 0 रखते, y इज इक्वल टू 5/2 मिल गया आपको, ठीक है। x इज इक्वल टू 1 रखे, y इज इक्वल टू 1 आ गया, ये भी है यहाँ। x इज इक्वल टू 2 रखे, y इज इक्वल टू -1/2, वो भी मिल गया। नाउ इट इज अ फंक्शन फ्रॉम A to B. तो दिस इज व्हाट वी आर गोइंग टू डील विद प्रिंसिपल। ऐसे ही फंक्शन से हम लोग ज्यादा काम करेंगे और ये सारे फंक्शंस की कैरेक्टरिस्टिक ये होगी कि अगर आपका कोई इक्वेशन फंक्शन के कंडीशंस को सेटिस्फाई कर रहा है तो आप उस इक्वेशन में y को आइसोलेट करके x की सारी चीजों को एक तरफ लिख सकते हैं और इसी एक्सप्रेशन को हम लोग कहते हैं कि ये fx है। इसी इक्वेशन को हम लोग कहते हैं कि ये हमारा fx है। तो जो फंक्शंस हम लोग डिस्कस करेंगे तो अब हर बार पूरी बात को नहीं करेंगे और y इज इक्वल टू fx फंक्शन है तो ये फॉर्म उसमें आएगा, ये फॉर्म उसमें रहेगा। तो जब भी हम लोग फंक्शन की बात करेंगे तो हम लोग केवल fx की बात करेंगे, ये fx हो गया। हमको पता है कि ये जो इक्वेशन है वो y इज इक्वल टू fx है। तो जो भी आगे का डिस्कशन होगा उसमें हम लोग fx की बात करेंगे, डोमेन जरूर डिसाइड करेंगे, लेकिन कोडोमेन की जगह मान करके चलेंगे कि सेट ऑफ ऑल रियल नंबर्स, और जो भी प्रॉपर्टीज हैं इस बेसिस पे डिस्कस किया जाए। लेट अस मूव अहेड और डिस्कस करें अपनी प्रॉपर्टीज को फंक्शंस के, और जहां जहां जैसे और जरूरत पड़ेगी फंक्शन के और डेफिनेशन से जुड़ी हुई बातों को तो उनको भी रिवाइज करते चलेंगे। one-to-one functions. Also injective functions. A function f from A to B is said to be a one-to-one function provided x1, x2 belonging to A, x1 not equal to x2 implies fx1 is not equal to fx2, or fx1 is equal to fx2 implies x1 is equal to x2. Any one of these two conditions can be used to say whether a function is 1-1 or not. तो जब भी कोई फंक्शन 1-1 है ये कहना होगा तो ऐसे में इस इक्वेशन का यूज करेंगे। ये शो करना है कि हमारा फंक्शन 1-1 नहीं है तो ऑल आई नीड इज अपने डोमेन में दो ऐसे नंबर्स हमको चाहिए जो कि बराबर न हो, लेकिन fx1 और fx2 बराबर आ जाए। fx1 और fx2 बराबर हो जाएगा तो फिर आपका कंडीशन सेटिस्फाइड नहीं होगा, फिर आप कह सकते हो कि 1-1 नहीं है। तो जब भी ये क्लेम करना रहेगा कि 1-1 नहीं है तब तो ये बड़ा अच्छा है, लेकिन जब ये क्लेम करना होगा कि 1-1 है तब हमको इस इक्वेशन से काम शुरू करना है और यहां से शुरू करके हमको दिखाना कि देखिए ऐसा है तो ये बस इतना है, इसके अलावा और कुछ नहीं है। तो जो भी पाते हैं तो एक दो एग्जाम्पल्स देखा जाए क्या करेंगे आप। f from R to R, ये ठीक। अब y इज इक्वल टू एफ एक्स अब बार बार नहीं लिखा जाएगा, मान लीजिए कि एफ आर टू आर है, एफ एक्स हमने एक्स स्क्वायर लिया, तो एफ एक्स हमने एक्स स्क्वायर लिया तो आप देखेंगे कि एफ वन इज ऑल्सो वन एंड f of -1 is also 1। इतना काफी है कहने के लिए कि ये फंक्शन हमारा 1-1 नहीं, क्योंकि x1 x2 ये बराबर नहीं है लेकिन दोनों की वैल्यू बराबर आ गई, ये फंक्शन आपका 1-1 नहीं। सीधे शब्दों में 1-1 का मतलब ये समझना है कि फंक्शन अपने किसी भी वैल्यू को रिपीट नहीं करेगा, किसी भी वैल्यू को रिपीट नहीं करेगा। एक बार एक वैल्यू ले लिया तो अब दूसरे किसी इनपुट पे उस वैल्यू को नहीं देगा। तो हमने मान लीजिए कि एक दूसरा एग्जाम्पल एंड आई कीप एफ एक्स से एक्स स्क्वायर। नाउ दिस इज 1, दिस इज नॉट 1-1 and this is a 1-1 function. Now how do I prove this? So we will start with, say, 2x1 x2 greater than 0 and fx1 is equal to fx2 will give me x1 square is equal to x2 square, which will in turn imply that x1 is equal to x2 or x1 plus x2 is 0. This is not possible because both of these are positive. Hence fx1 is equal to fx2 gives us only x1 is equal to x2, and therefore the function is a one-to-one function. Now, whenever you have to prove that it is a one-to-one function, it's always better to start with fx1 is equal to fx2. But there are other ways also of looking at this. Say when I want to quickly judge for myself whether I am looking at a one-one function or not, whether my function is one-one or not. So there are other ways. You can take help of the derivative. Derivative, what should I look for in the derivative? So if you have a function whose expression can be differentiated with respect to x, say for example fx is x squared. So f prime x or the derivative of fx with respect to x is we have f prime x is equal to 2x. So what should I look at in this derivative? To know that the function is a one-one function, this is very simple. On your domain, say the domain here is set of all real numbers, the domain here is set of 0 to infinity. On the domain, the derivative should either be always positive or always negative. It should not change its sign from positive to negative. So on this domain, the derivative happens to be both positive as well as negative. But when I take a domain from 0 to infinity, the derivative is positive. And hence, by just looking at this derivative also, we could have said that my function is a one-one function. To decide a one-one function, another fact which we can take advantage of is certain xy plots, certain expressions are familiar to us and their xy plot is easily recognizable, or I understand the xy plot quickly. Say y is equal to x square. The xy plot is like this. So if you take a domain of your function from R to R, you will get this entire plot. Every point of this plot will be in your function, graph of the function. But when you take the domain from 0 to infinity, only this part, from 0 to infinity, if your domain is only from 0 to infinity, then you are having only this part of the graph. So what is it in this graph which I must be looking for to say that I am coming across a one-one function? Again, the answer is very simple here. Any horizontal line, if it is a one-one graph, cannot cut it more than once. And if it is not a one-one function, then a horizontal line will necessarily, one or the other horizontal line will cut it at two different places, maybe more also. So either it will cut or it may not cut at all, but it will be cutting only once if it is a one-one function. Now these are two things which we should be relying upon when I have to quickly judge. Say for example, when I was asking objective questions, you will not go on to solve this equation, it is going to take time. लेकिन अगर आपको स्कूल का इम्तिहान देना है, सब्जेक्टिव आंसर लिखना है, तो फंक्शन हमारा वन-वन है कि नहीं है, उसके लिए एक आंसर लिखना है, चाहे नंबर लेने हैं, दो नंबर लेने हैं, तो फिर ये ग्राफ, ये डेरिवेटिव, ये लॉजिक probably एक्सेप्ट नहीं होगा. डेरिवेटिव एट अ लेटर स्टेज, बिकॉज इट इज अ पार्ट ऑफ एप्लीकेशन ऑफ द डेरिवेटिव, हो सकता है एक्सेप्ट हो जाए. लेकिन जब ये क्वेश्चन पूछा जाएगा स्कूल में कि वन-वन शो दैट दिस फंक्शन इज वन, तब आपका स्टेप यही होना चाहिए कि fx1 इज इक्वल टू fx2 से शुरू कीजिए और कहाँ पे जाके खत्म कीजिए कि अब वहां से केवल एक ही पॉसिबिलिटी ही निकल रही है, x1 इज इक्वल टू x2, और कोई दूसरी पॉसिबिलिटी आ रही है तो वो रिजेक्ट हो जानी चाहिए. जैसे यहाँ हमने किस बेसिस पे रिजेक्ट कर दिया इसको, हमने इसको इस बेसिस पे रिजेक्ट कर दिया कि हमारा x1 और x2 दोनों जीरो से बड़ा है, तो x1 प्लस x2 कभी भी जीरो नहीं हो सकता है. तो कभी भी जो स्कूल में आपको इस तरह के क्वेश्चन के आंसर करने हैं, स्कूल के एग्जाम के सब्जेक्टिव आंसर की, जिसमें कह शो दैट दिस फंक्शन इज अ वन-वन फंक्शन, तब ध्यान रखिएगा कि आप ये इक्वेशन से शुरू करें और सॉल्व करके बस उसमें यही एक पॉसिबिलिटी है और दूसरी कोई पॉसिबिलिटी यहाँ पे बनती नहीं है और क्लेम हो जाएगा कि ये फंक्शन वन वन। ऑब्जेक्टिव काम करते समय थोड़ा सा ये सब काम करके टाइम लगाने से अच्छा है कि अगर आपको प्लॉट ध्यान पे है तो प्लॉट तो फिर मन में ही देख के बता सकते हो और नहीं तो फिर डेरिवेटिव में क्या देखना है, तो डेरिवेटिव अपना साइन चेंज करे। जीरो हो सकता है लेकिन जीरो भी ये नहीं हो कि जीरो एक इंटरवल पे लगातार है। यू कैन हैव अ फंक्शन विच इज अ वन वन फंक्शन whose derivative is zero at isolated points। एक एग्जाम्पल लेते हैं, R टू R लगाते हैं और R टू R में fx ले लिया जाए x प्लस साइन x। अब इसका डेरिवेटिव लिखिएगा तो ये आ रहा है 1 प्लस कॉस x। तो डेरिवेटिव 1 प्लस कॉस x आ रहा है। अब ये जो डेरिवेटिव है f प्राइम x इज इक्वल टू 0 एट x इज इक्वल टू ऑड मल्टीपल्स ऑफ पाई। लेकिन ये आइसोलेटेड पॉइंट्स है, एक बार जीरो हुआ फिर तुरंत पॉजिटिव हो जाएगा। तो इन पॉइंट्स को छोड़ दीजिए तो जीरो हो रहा है एक पॉइंट पे, तो ये केस भी आप कहेंगे कि हमारा फंक्शन वन वन है। लेकिन ये नहीं होना चाहिए कि डोमेन के इंटरवल पे कंटिन्यूअसली आपका डेरिवेटिव जीरो हो जाए, तब फिर आप उस फंक्शन को वन वन नहीं दे सकते, क्योंकि डेरिवेटिव का जीरो हो जाना ओवर एन पार्ट ऑफ अ डोमेन का मतलब हो गया कि उतनी दूर पे आपका फंक्शन कांस्टेंट हो गया है। कांस्टेंट फंक्शंस आर नेवर वन वन फंक्शंस, क्योंकि वो तो हर इनपुट पे सेम वैल्यू देते हैं। तो जीरो हो सकता है डेरिवेटिव, आप फिर भी क्लेम करोगे कि हमारा फंक्शन वन वन है, प्रोवाइडेड आप ये देखें कि वो जीरो आइसोलेटेड पॉइंट्स पे अकर कर रहा है, कंटिन्यूअसली किसी इंटरवल पे अकर नहीं कर रहा है। सो दिस इज व्हाट आवर वन वन फंक्शन इज। The second characteristic that is we are going to look at today is onto functions. Onto functions, the next property of functions that we are going to look at. A function f from a to b is said to be onto provided for every y belonging to b there is an x belonging to a such that x comma y belongs to f, that is y is equal to fx. So if this happens, then we say that the function is onto. This definition, if you will look at, is very much like what we say when we define function. When we define function, we say that for every x belonging to a, here we are saying for every y belonging to. The difference is that when we say that in function, for every x belonging to a, there is a unique y belonging to b. But here what we are saying is for every y belonging to b, there has to be x. There can be more than one x in a such that y is equal to fx. Now this is, if you look at it closely, that is what we were saying initially when we defined function, that in general we say that a function is from a into b, because range most of the time happens to be a subset of codomain b. Now in this case what will happen is that the range will become equal to b. So function is onto, in simple terms, it is basically saying that the codomain is nothing but the range of the function. Codomain is nothing but range of the function. So whenever you are trying to say that a function is an onto function, all you need to look is whether your codomain b is equal to range of the function. And if that is not the case, then you say that fx is an into function. And if it is equal to the codomain, then we will say that it is an onto function. So let us look at a few examples here. so that this idea also settles in properly. Let's take our first example in this case. If from R to R, fx is equal to sin x. Now, our exposure to sine over the period of time has given us to understand that values of sine x lie between -1 and +1. So because of my familiarity, I know this function which I am using, fx sine x, it has a range from -1 to 1, and here the codomain is set of all real numbers. So certainly your range is not equal to the codomain, so you will say that it is not onto. On the other hand, if I define f from R to -1 to 1, and again take fx is equal to sine x, then the codomain here has been replaced by exact range of this function, and hence this is an onto function. Now suppose you have a subjective question to answer, then what argument you must produce there? So if you want to say that it is not an onto, then you already know that the range is -1 to 1. What you do is, you take any number outside the range from your codomain. Say, let 2 belong to codomain R. Now there is no x such that sine x is equal to 2. And the definition said that for every y belonging to B, there must be an x such that y is equal to fx. Now for 2 in this codomain, there is no x in domain such that sine x is equal to 2. So if I take 2 and there is for no x, sine x is equal to 2. Therefore, I am not able to find an x in my domain such that sine x is equal to 2. Hence the function is not an onto function. So that is what the idea of onto is. So whenever you come across this phrase that let f be an onto function, that means the given codomain is being given to you as the range of the function. A function which is both 1, 1 and onto. A function which will be both 1, 1 and onto will be referred to as a bijective function. A function which is both 1, 1 and onto will be referred to as a bijective function. Let us want a few more examples here. Say fx is equal to 2x minus 1, and f is defined from 0 to 3 to -2 to 10. Now simple arithmetic sense will tell us that if x is between 0 to 3, this will imply that 2x minus 1 will be a number between -1 and 5. That is, the range of f is -1 to 5, which is not equal to the codomain. Hence, not onto. Now that is our understanding. Now if I have to give an answer for this, then this probably will not do a good answer for this. So by the definition, now I understand the range is -1 to 5. So I'll take a let y equal to 6. See, y belongs to -2 to 10. Now y is equal to fx will give me what? 6 is equal to 2x minus 1, which will give me x is equal to 7 by 2, which does not belong to the interval 0 to 3. So for given y, I have not been able to find an x in my given domain, and hence I will claim that the function is not an onto function. So whenever you are trying to answer these type of questions subjectively, this is what your steps should be. The definition is going like that. But when you are trying to look at it objectively, then you must be very clear that range, if I understand the range and range is not equal to codomain, then I don't have any hesitation in saying that the function is not an onto function. And if the function is, the range happens to be equal to the codomain, then we will say that it is an onto function. We will now look at certain examples where both these characteristics we will try to understand. Remember that in order to justify that I have a 1-1 function, a quick approach is, if I have an xy plot of my function, or if I have a derivative for the expression of my function, they are good at deciding whether the function is 1-1 or not. And onto, so if you have your range, the range is equal to codomain, then the function is onto. Now look at this question. F is defined from A to 0 to 1. Fx is sin x. A. B. Fx is cos x. Find A so that f is both 1-1 and onto. Now such questions, if the expression fx, y is equal to fx, xy plot is easily available, then the plots give us a very clear idea about what is happening in the function. So wherever they are clearly available, easily available, we must look at them. So y is equal to sin x. Y is equal to sin x is a plot like this. The entire plot varies between -1 and +1. So if I take the entire plot, so the entire plot means if I take set A, a set of all real numbers, I get values from -1 to +1. But then I am only interested that my function is both 1-1 and onto, so my function must have a range equal to how much? 0 to 1. Therefore, I can only use this part of the plot. I cannot use this part of the plot, the part which is lying below x-axis. Now, if I use only this part, so I can take a domain from 0 to pi. I can take a domain from 2 pi to -2 pi to -pi. Similarly, if you go ahead, there will be 2 pi to 3 pi. So if you choose these domains 0 to pi, 2 pi to 3 pi, 2 pi minus 2 pi to minus pi, then you are ensuring that your function is onto. But then I also want that my function is what? 1. So if I take this entire domain, so I will get this part of the plot. And in this part of the plot, a line like this is going to cut it at how many times? 2 times. So if it is cutting 2 times, the function can never be a one-to-one function. I want my function to be both 1, and onto. So again, I cannot choose the domain as 0 to pi. So for A, what are my various possibilities? For A, I can choose a part such that I get all values between 0 and 1, but no value is repeated twice. It can be from 0 to pi by 2 or pi by 2 to pi. Similarly, there can be so many others. There can be another one which will start at 2 pi. 2 pi will start and end at which place? 3 pi by 2. I'm sorry, pi by 2. And so on. So you can give several examples of A or several possibilities of A so that fx is equal to sin x is both 1 and onto. Similarly, if you will look at the graph of cos x, there will be several possibilities here also. Why don't you give a try? Take a time, take a minute and say what intervals you will say here. Again, you will get 0 to pi by 2, all right. This is first quadrant, but this time you will not get pi by 2 to pi because in second quadrant cos happens to be negative. Then again third quadrant is cos negative. Then you will take entire fourth quadrant. So another choice can be minus pi by 2 to 0 or 3 pi by 2 to 2 pi. These can be your choices, and that will ensure that if you choose for sin x A to be any one of these intervals, then your function will be both 1 and onto. And for cos x it can be 0 to pi by 2, this, or any other such interval which has angles, only all the angles of the first quadrant or all the angles of the fourth quadrant. Then you are ensuring that your function is both 1 and onto. Try another one. Remember the plot of xy plot of y is equal to modulus of x minus 1. How many of us remember it? You can quickly draw it. So, draw this. Y is equal to modulus of x minus 1. This is how it is going to look like. This tip is where? This tip is at x is equal to 1. Your y-axis will be somewhere here. Y-axis is getting cut at 1. These are lines. Y is equal to x minus 1. This is y is equal to 1 minus x. Now suppose you have this plot. Looking at a function like fx, which is given as modulus of x minus 1. And again, the same kind of question. A to, let us say we are giving here 0 to 2. So, A, what should be my domain so that f is bijective? F is bijective is same thing as f is both 1 and onto. So, if I understand how to interpret my plot, then I want my range to be from 0 to 2. That means my y coordinates must vary only between 0 to 2. So 1 is here, 2 is here. So if I draw a dotted line here, can I make a judgment where it is going to cut my x? So if I use my equation correctly, y is equal to 2 modulus of x minus 1. So this will come out as 3. This will come out as minus 1. And now by looking at this particular plot, this particular question can be answered. If I want my function to be only onto, I can take my domain as from minus 1 to 3. Any one of these parts should be there entire, or some part of these interval from minus 1 to 1 or from 1 to 3. But one of these line segments must be there fully. So to ensure that it is onto. But if I am interested in bijective, then I cannot take a domain such that the plot has part of this line as well as part of this line. Because then there will be horizontal lines which will be cutting it at two different places. This I do not want. Why? Because we are interested in a 1-1 function as well. So what is our judgment then? What should be our A here to say that my function is both 1-1 and onto? So we will say that A can be either an interval starting from 1 to 3, or A can be an interval from minus 1 to 1, or A can be an interval from minus 1 to 1. Can I take an A, say, minus 1 to 0? Minus 1 to 0 will be giving us this part of the graph. That means my values will be from 1 to 2. And then I choose from 1 to 2. 1 to 2. Then this part. This part. This is how this is can be also a possibility for A. Part of the interval from here and part of the interval from here, but such parts so that the values do not get repeated, because the value will get repeated, then which property will be lost? If the value gets repeated, the 1-1 property will get lost. And also I have to ensure that every value between 0 and 2 is there. If that is not the case, then what will happen? If every value between 0 and 2 is not there, then I cannot claim that my function is an onto function. Because for an onto function, my range must be equal to co-domain. So I have to ensure both the things, that every value is ensured and no value is coming twice. So that is why you will see that I have to at 0, I am putting a closed interval. And at 2 I am putting an open interval. What happens? At 0 as well as at 2, this is going to give me the same value. 0 also the y value will be equal to 1. 2 also y value will be equal to 1. So I cannot allow both 0 and 2 in my domain. If I allow both 0 and 2 in my domain, then I lose which property? I lose the 1-1 property of the function. So either I have to keep 0 or I have to keep 2. So if this is closed at 0, I have to keep it open at 2. So you can create many such examples of it. There is just not one example. If you want without a break, then there are only two possibilities. If you want the domain as a continuous interval without any break, then there is only two possibilities. If 1 to 3 or from minus 1 to 1. So that this entire line segment is there or this entire line segment is there. But if that is not the condition, then there can be many possibilities for A to ensure that the function is a bijective function. So that is it. For today we will keep it here, and when we meet next, we will talk some other properties of the functions, some more operations on functions which we have not discussed earlier, and of course, henceforward, wherever we need, wherever these things are coming, we will keep coming back, doing questions from here, and we will try to put up certain problem sheets. So you can download those problem sheets, try at your own, and get your ideas clear for what are my 1 month functions and what are my on-2 functions. Okay, so we meet next, and then when we meet next, we will be doing composition of functions. So next time when we meet, we are going to talk about composition of functions. Okay, thanks.